Hey everyone, and welcome! If you're getting ready for the DRDO's Senior Technical Assistant exam, you know how important it is to have your core concepts down cold. So today, we're going to break down two really important questions, one from physics, one from biology, and get into the method of how to solve them, not just the answers.
Look, you want to nail this exam, and we want to help you do it. So let's sharpen those skills and tackle these problems together, one step at a time. First up, we're diving into some physics.
All right, let's jump right into the world of physics. We're starting with a classic problem that involves a car, some braking, and of course, force. This is exactly the kind of question you'll see on the exam because it tests a really fundamental principle.
Okay, here it is. We've got a car, 1,000 kilograms, moving at 30 meters per second, and it needs to stop, completely stop, in just 4 seconds. The question is, what's the braking force required to make that happen? Now take a quick look at those options. See how some are positive and some are negative? That's a huge clue about what this question is really getting at.
Before we can even touch the numbers, we need the right tool for the job. And for a problem like this, our go-to tool is Newton's second law of motion. You know it. Force equals mass times acceleration, or F equals m times a. This little formula, it's the key to the entire thing.
So, how do we use it? Well, it's a simple two-step process. First, we've got to find the acceleration, or in this case, since the car is slowing down, it's actually deceleration. For that, we use the formula where a is just the change in velocity over time. Once we have that number, we just plug it straight into F equals m times a to get our final force. Easy enough, right? Let's run the numbers. First up, acceleration. The final velocity is 0 because we're stopping, and the initial was 30. We divide that by the time, 4 seconds. So 0 minus 30 is negative 30. Divide that by 4 and you get an acceleration of negative 7.5 meters per second squared. Now for step 2, we plug that into F equals m times a. So that's 1,000 kilos times negative 7.5, which gives us our answer, negative 7,500 newtons. So what's the deal with that negative sign? It is so important. It's not just some random minus. In physics, that sign tells you everything about direction. It means the force from the brakes is being applied in the opposite direction of the car's forward motion, which, makes perfect sense. That's exactly what brakes are supposed to do. Okay, let's switch gears completely. We're leaving physics behind and jumping over to biology. We're going from the mechanics of a moving car to the tiny inner workings of a plant. This next question is all about identifying the pieces of a super important plant tissue. And here's our biology question. We're asked to find the combination that includes only the living components of something called phloem tissue. This is a classic classification question. It's testing if you can remember the different cell types and what they do. So to get this right, you first have to know what phloem is even made of. It basically has 4 main parts. You've got sieve tubes, companion cells, and phloem parenchyma. And as you can see, all 3 of these are living. But then there's the 4th one, phloem fibers, and that's the odd one out. It's the only part that's dead. And here's the key to remembering this. Think about their jobs. The 3 living components are all busy doing the main job of phloem, which is transporting food around the plant. They're the active workers. The one dead component, the phloem fibers, it has a totally different, more passive job. It's just there to provide structural support, kind of like the steel frame of a building. So with that in mind, the answer becomes pretty clear, right? The only combination that lists only the living parts is, of course, sieve tubes, companion cells, and phloem parenchyma. If an answer choice includes phloem fibers, you know it's got to be wrong for this question. Okay, so we've tackled 2 really different types of questions. So what's the big picture lesson here? What are the core strategies that you can take from this and use on other problems? Let's quickly sum it all up. For the physics problem, the takeaway is simple. Always, always pay attention to the signs. That negative sign wasn't a mistake. It was a critical piece of information about direction. For biology, the strategy is to connect the structure to its function. The living parts are doing the active work, transporting food, while the one dead part is just there for passive support. If you can remember that connection, you'll have it down. So we've walked through these questions and pulled out the key ideas. But just watching isn't enough, right? The real learning starts now, when you take these concepts and start applying them yourself. And that brings me to my final question for you. Now that you're thinking about directional force and classifying components by their function, where else could these ideas pop up on your exam? How can you use what we just did to solve the next tough problem you run into? Keep practicing, keep thinking, and you're going to do great.